To a computer, a photograph is a grid of numbers, brightness values, row after row, nothing else. No cat, no face, no sunset. Just numbers. Somehow, machines learn to find the cat anyway. This is how machines see. The naive move fails immediately. Wire every pixel to every neuron, and a 1 megapixel image needs billions of connections in the first layer alone. Vision needed a smarter idea, and it borrowed one from the eye itself. Look at small patches. The smarter idea is the kernel, a tiny stencil of numbers 3 by 3 that slides across the whole image. At every stop, it multiplies sums and moves on. One kernel, one pattern, hunted everywhere. The output is a map of where the pattern happened. A kernel tuned for vertical edges redraws the image as its edges. Another finds corners. Another blobs of color. Each kernel sees one thing, and together they see texture. And here is the part that matters. Nobody writes those stencil numbers by hand anymore. They are weights. The network learns its own kernels by gradient descent, the same downhill walk from episode 1. The machine invents its own eyes. Then you stack. The first layer finds edges. Next combines edges into shapes. Then shapes into parts, and parts into things. Whiskers. Then a muzzle. Then a cat. Depth turns pixels into vocabulary. Between layers, the maps shrink. Pooling keeps the strongest signals and drops the rest. So a cat shifted 3 pixels. Sideways is still, plainly, a cat. The network stops caring where the pattern sits and starts caring that it exists. License plates, tumors, faces, galaxies. The same small stencil, sliding across a grid of numbers, stacked deep enough to name what it finds. That's how machines see.